Welcome to AEC Examples number 6 in the structure section. Example number 6 is asking us to solve for the reactions R1 and R2 and to neglect the weight of the beam. So this is a beam. We're we need to figure out this reaction and this reaction. In reality, typically what you'll want to do is this will be a simple beam and you'll have one of them will be a pin and one of them will be a roller or a slider or however you want to call it, and it won't prevent moving in the x direction. This will, but since there's no forces in the x direction, this will be 0, so it cancels out and you just get rid of it. Anyways, we're trying to find the result. So we have a free body diagram already. This is your free body diagram. So we have the three equations of equilibrium, I believe they're called. The sum of forces in the x direction equals 0. The sum of forces in the y direction equals 0. And the sum of the moments about any point equals 0. So you look at these and you're like, okay, I need to isolate one of these. How can I isolate one of these? Well, x direction, we don't have any force in x direction, so that ain't going to be it. And then you look at this y direction. Well, you have two forces in the y direction that are unknowns. So you can't really isolate one unknown. So it's probably going to be force in the moment, or sum of the moments about a point. And I would go ahead and call this A and B. This is A, and this is B. They didn't do that, but I will. So it doesn't matter which one you do about. If you do it about this, it gets rid of R2. R2 is 0 because the moment that R2 induces is 0 because it's a 0 distance because it's concurrent with that point. So you're going to be solving for R1. Or you could do the opposite. You could do the sum of moments about A, and the R1 doesn't induce a moment, so you'd be solving for R2. So let's go down here. Let's just do the sum of moments about R1. Sum of the moments about A. Sorry, sum of the moments about point A is getting rid of R1. That might have been a little confusing there. Sum of the moments about point A equals 0. So you get, let's go ahead and do your positive moment. That's going to be positive. So let's go from left to right. This is 0, we know, 5,000 pounds. And you could say that's negative 5,000 pounds or a negative foot. Let's just say negative 5,000 pounds times 5 foot. Once again, that's going to be negative. Oh no, that's wrong. That's going to be positive. I messed up. That's going to be positive because this is going to be going that way. So, and that's positive as we said 5,000 pounds and 5 foot. And then we will also have plus, we don't have anything else except R2. And that is at 15 foot. But since it's going to be negative, we have to make this negative. There we go. And that, we don't have any others, so there we go. That's what you got. 5,000, that should be what, 25,000 foot-pounds? And remember, equals 0. 25,000 foot-pounds. Or pounds times foot, or whatever. Plus a negative R2, 15 feet. Sometimes I put that in there to make it less confusing when I use units. Alright, now you want to move this. Actually, I'd move this to the opposite side. Since this is already positive, might as well take this, since it's negative, and add R2, 15 foot to it. Which it'll bring, over here, if you do it to this side, algebra, you have to do it to this side, plus R2, 15 foot. So you have R2, 15 foot. Now it's positive since we moved over here. These cancel out, of course. Equals 25,000 foot-pounds. Now, you want to isolate your unknown, so you divide by 15 foot. You divide this by 15 foot. And you get R2 equals 25,000 foot-pounds divided by 15 feet is going to leave you pounds, and that is 1,666.7 pounds. Get feet, it leaves you with pounds. And we're going to go ahead and check that with the answer. 1,667. Yeah, we just took it to one significant figure further, so we're good on that. Now we have this equals 1,666.7. And now you could do the same thing. You could go to B and you could sum the moments about B, and that would give you R1. Or you could do what I always prefer to do, is do the sum of the moments in the y direction. Now you only have one unknown in that equation, so you can solve for R1. Sum of the forces in the y direction equals 0. And you have positive 1,666.7 pounds. You have negative 5,000. And then you have a positive R1. Sorry, I couldn't figure that up there. So let's add these. Let's add these together, and you should get 0 equals negative 5,000 plus 1,666.7 is negative 3,333.3 pounds. Plus R1. And to isolate your R1, you want to add 3,333.3 pounds to each side. 3,333.3 pounds. And you get R1 equals 3,333.3 pounds. And I'm checking, and that is correct. So here are your two answers. You wanted to solve for your reactions. There's R1 is your reaction. R2 is your reaction. All too easy.